Hello again. This is Jim. I'm going to teach you a little bit of something about using the command sweep. There's a lot of people who do not understand how sweep works or how to use it. And it's primarily because they don't understand two basic rules about sweep. That is, if you're going to sweep an object, well, like this circle, for example, and you're going to use this particular path to sweep it along. Of course, we're working here in 2D. You'll have to use your imagination a little bit. But that object, this one in particular, is a 0.08 diameter, which means it has a 0.04 radius. Well, the curve right here, this curved area, has to have a wider radius than your object that you're trying to sweep. And you can see I've drawn this in that this is a point distance here is 0.04, and so you can see we still have a curve on the inside. If this object were to sweep this path right here, this is what that curve, the inside curve, would look like. Now if I tried to sweep along that smaller radius right there, you can see that's not going to make it. If I offset that thing 0.03, you're going to get a square corner, you see? And it's inside the radius of the object that you're trying to sweep. So this winds up in negative, this whole area right here, in that vicinity right there, that's negative. And physically that cannot exist. And so the program gets a little bit confused. Now there have been, and I imagine there still are some programs out there that can make that happen. But what they do is they extrapolate that past that point, and they give you kind of a figure eight. They'll sweep it. And that is really confusing. And in fact, I would imagine probably impossible to machine or to make or to print. So rule one is that you have to have an open polyline because the sweep has to know where to begin and where to end. And rule two is that any radiuses along your sweep path have to be equal to or larger than the object you're trying to sweep. Let's see, let's get this and put it up here. And or extrude along the path. And that seems a little rather intuitive, doesn't it? It seems like, well, anyone would know that. But unfortunately, it's not the case. A lot of folks don't know that. They'll try to come up with a closed polyline and then sweep along a closed polyline, and the program says, well, where do you want me to start? Remember, a closed line does not have a beginning or an end, just like a circle. Has no beginning, no end. So the program is just, the simple way to tell the program what's the beginning and the end is just to have an open polyline. Now you can have that polyline closed down to almost infinity. You can have it closed down to a millionth of an inch as long as it's not closed. They can be close, but not closed. Now think about your 3D printer, for example. If you were trying to 3D print an object that you swept along a path, and you left a gap less than the resolution of your printer, say your printer is printing on 1/10 of a millimeter. Well, if your path was open less than 1/10 of a millimeter, wouldn't a 3D printer go ahead and print over it? It would print right past it. It wouldn't even recognize it as a gap. But the drawing would know there was a beginning and an end for the sweep. Now in the next video, I'll go ahead and demonstrate this principle, and I think you'll have a little bit better understanding of what I'm talking about. And I think you'll be able to make much more successful sweeps using these different 3D STL producing file 3D model programs. I don't want to mention any names. That's why I'm kind of stuttering around about that. But anyway, I'll demonstrate it in my next video, part 2. Thank you for watching.